Alright, hello everyone and welcome back to the POPX Introduction tutorial. If you haven't watched the previous tutorials, I highly recommend you to watch them before you continue with this tutorial. The link is down below the description. In this tutorial, we're going to focus on two modifiers, the Relax modifier and the Magnetize. Let's start with the Relax modifier and drop it in our network. So the Relax modifier basically applies a relaxation force based on a relax radius and max neighbors. And we have several modes over here that we will going to explore. So basically, the relax force is separating the points apart, and or the points or the instances depends on what kind of geometry you're going to work with. Um, so I have here a geometry, and I want to instance about a bunch of spheres inside the volume of this geometry. So I'm going to grab a sphere and connect it into an instancer. And in the distribution page, I'm going to choose a mesh and reference the geometry that we have here onto the template object. Let's display it. Now the spheres are too big, so I'm going to decrease their um, radius, maybe even more. And I'm going to go to the mesh settings, and in the mesh distribution method, select the scatter and scatter method to be a volume. So now I have some points that are scattered inside the volume. Maybe I can increase the amount. And actually I want to make them a bit smaller. Okay, so now I'm going to connect those to the relax modifier. And immediately you can see that our points are got separated, and you can decrease the relax strength and make more iterations. Um, Now the solver is in a simple mode, so basically it's not advecting or solving iteratively over time, but I can choose it to be an advect mode, and you can see that it's gradually applying the relax effect. I can drop a keyboard in to reset the advection and reference it over here on the start pulse. Great. Now we can play around with the max neighbors. We don't need that much, I think, for that particular example. Now, a nice thing about the relax is you can constrain the relaxation based on a geometry, which will basically constrain it onto the surface of any geometry you input or to a volume. Let's start with the constraint geometry. I'm going to apply it with the geometry that I have here and toggle on the constraint to the geometry, and let's display the geometry. And as you can see, the instances are constrained to the surface of the geometry. We can also increase the max neighbors, maybe make more iterations. Now in places that the uh, maybe less, something like that can be cool. So in places where the curvature is very high, this doesn't work pretty well. Um, but you can solve this with maybe constraining to a solar volume that we'll going to look at right now. So let's um, toggle off the constraint to geometry. And now I want to basically convert the geometry into a volume, which it's going to be represented by a 3D texture. For that, I'm going to use the Voxelize tool. and connect my mesh into it. Now the Voxelize tool can voxelize a mesh or point cloud. Currently we want to voxelize a mesh. Let me just init our simulation so it won't interfere. When you connect, you can choose the max axis resolution, and to get the correct voxelization, you need to get the right bounds of your mesh. By, by doing it very quick, you can just post the get bounds, and this will compute the right resolution of the 3D texture. So now we have our mesh represented by a volume, and we can connect it into the relax third input, the constraint volume, and apply the constraint to volume. Now if I reset the simulation, something doesn't look quite right because we need to reference our lower bounds and upper bounds in over here on the relax. So let's do this. I'm going to reference it and also the upper bounds and reset the simulation. Let's also visualize our mesh by converting it into a wireframe. So I'm choosing the convert pop to be triangles, quads, and lines to line strips, and I'm going to just display it. So you can see now that our most of them of our instances are constrained inside the volume. There is one that escaped. Maybe if we increase the resolution here, it will help him, or not much. To solve this, maybe we can um, transform or make the initial position of our instances a bit more inside the sphere, or choose maybe another seed so that all of them will be initially inside the volume. A nice thing you can do is to connect a null over here, and in the relax page you can reference this null to basically apply more stuff in between. So for example, I can apply just simple noise pop, and obviously it's way too strong, so I can decrease the amplitude, and now I have some movement inside the volume, but there is still constraint to the volume. Now I can animate the noise to make it more interesting, and maybe increase the relax force to separate them more. Cool. So this was the relax modifier. Very useful if you want to create those kind of stuff. Let's move on to the magnetize. I'm going to delete all of those, and let's instance boxes, and I'm going to reset all the settings to default to apply a grid distribution. Let's increase the size, and actually I want to also increase their grid resolution to something like this, and maybe scale it maybe even more. All right, so let's drop the magnetize. So the magnetize applies a forces, whether it's a repulse, attract, or spin forces onto the uh, points or instances. So if I connect the instancer into the magnetize and I display, So I can see that the default magnetize, it has a position at the center at 0, 0, 0, and I can choose the effect radius to be increased. And magnetize is a solver, so I can reference the keyboard in to restart my simulation. And if I move my magnet over here, you can see that the not on the y-axis because we're not on this plane, but if I move it on the z-axis or x-axis, you can see that the the instances or points that are closer to the magnetize are being affected, and I can choose to a different force like attract and maybe increase the force strength. Whoops. And also spin. Maybe to see it better, I can increase the scale it on the z-axis, and then I can apply also the effect rotation and aim weight to 1. Let me decrease the size, overall size. And also I can not affect the position but only the rotation if I want. Oops, I'm always changing the y-axis. Okay. Now there is also the exponent, which will also affect the amount of effect. And to see it better, actually, we can output the weight attribute over here and apply color based on the weight. So I'm going to add a color modifier, display it, and choose the weight. So now we can see our weight better, and we can see the effect of the exponent. I want to affect the position also. Now, a nice thing about the magnetize that you can input any kind of like points, and you will have multiple magnets. So for example, I can use a point generator with rectangle, which will be facing on the z-axis plane. And let's have like 3 of those points. And let's animate them with the noise. I'm going to change it here to 3, but I won't want to make them animated on the y-axis, only on the x and z-axis. Let's animate it here with appstime.seconds. And connect them into the magnetize. So to see it better, we can visualize it over here. And maybe let's increase the amplitude of the noise. Maybe more. Even more, maybe. Yeah. No, I think less. Something like that. And let's see the weighting. Now, a nice thing is that we can also control each of the magnets force mode or effect radius or force strength exponent and every basically parameter here based on attributes. So I can create um, an attribute with the same name, for example, radius. So I can hover on and see that the effect radius name is radius, but without capital letters. So for example, radius. And immediately I don't no longer have access to this because now I'm controlling it through the attribute. To see it better, we can display the magnetize itself and you can see the effect. Now you can do this also for the force strength, the exponent, and the spin direction. So for example, for the mode, currently it's spin. So I can choose to create a mode attribute. And if it's 0, it's going to be a repulse force. If it's 1, it's going to attract. And 2, it's going to spin. Now you can also create individual points, for example, with a point pop, and apply um, different attributes to each of one of them. So I have 2 points, and I have 1 point with a radius like this, and it's going to spin. And another point I wanted to basically repulse. I can merge them and maybe change the position over here. And actually I can also connect it to the noise to animate those two, and maybe decrease the radius to see the effect better. Let's see it with the weighting, with the color. Let's reset. Um, and maybe the animating noise, let's reduce the speed and maybe more radius for each one. So you can see that one of them is actually rotating and spinning, and the other one is repulsing. And you can see maybe more if I toggle off the position, and only the rotation is being affected. So they are kind of like too close to each other, I would say. Mm, yeah, so you see one of them is uh, the rotation is like a spin rotation, and the other one is repulse rotation. You can also play with the search radius and the relaxation factor. So for the relaxation factor, if um, uh, the points or the instances are no longer affected by the magnets, they will basically return to their original position and orientation. Let's increase the noise. So the relaxation factor uh, uh, makes it affect how fast they are going to return to their original um, orientation or scale. And obviously you can make hundreds, or I don't know if you want to make hundreds, but lots of points of magnets to create like nice orientation variations and movement along your instance geometries. I can also maybe scale them based on the weight. So let's grab a transform modifier and maybe scale them. So the more they are affected by the magnets, they're going to scale. Let's maybe reduce the radius. All right. So yeah, this is the Magnetize. I hope you will find a way to use it and create nice stuff. Um, this is the end of this tutorial. Um, in other tutorials, I'm going to walk through every simulation. It's going to be a very deep tutorials on every simulation basically, and also there is going to be more tutorials about specific like networks inside the POPX system that I will be also share files and example files and ready production files. Thank you for watching, and I hope it was useful for you, and I will see you in the next tutorial. Bye bye.